According to the National Electrical Code, Article 517, isolated ground circuits require a 4-wire configuration. This includes 1 hot wire, 1 neutral wire, 1 isolated ground conductor, and 1 equipment grounding conductor. The isolated ground conductor can be number 12 American wire gauge or larger insulated copper. The equipment grounding conductor can be sized according to National Electrical Code Table 250.122 and must be insulated. A tenant may request a 4-wire branch circuit with all conductors number 12 American wire gauge. This is compliant with the National Electrical Code as long as the isolated ground conductor is insulated. Hospital-grade AC cable installed may have an armored sheath that serves as the equipment grounding conductor. While this is acceptable under the National Electrical Code, the tenant might prefer a separate insulated wire for the equipment grounding conductor. Several reasons could explain the tenant's preference. Firstly, specific equipment requirements may dictate the need for a dedicated equipment grounding conductor to ensure proper grounding and prevent interference with sensitive electronic equipment. Secondly, an insulated wire equipment grounding conductor is often easier to identify and troubleshoot if issues arise during maintenance. Thirdly, the tenant may simply prefer the appearance of a separate wire equipment grounding conductor compared to an armored sheath. Ultimately, the decision and the type of wiring often rests with the tenant. Even if the hospital-grade AC cable with an armored equipment grounding conductor is code compliant, valid reasons might exist for the tenant's preference. To resolve potential disagreements, consider the following options. Firstly, accommodate the tenant's request by repulling the wiring and installing a 4-wire branch circuit with all number 12 American wire gauge conductors, including an insulated wire equipment grounding conductor. Secondly, negotiate with the tenant, explaining the benefits of using the hospital-grade AC cable with an armored equipment grounding conductor and attempt to convince them to accept it. Thirdly, seek approval from a higher authority, such as contacting the building owner or a local electrical inspector, to get their opinion and determine if the tenant's request is reasonable. When dealing with isolated ground circuits, several technical aspects need to be understood to ensure proper installation and compliance with electrical codes. Firstly, the purpose of an isolated ground is to minimize electrical noise and interference in sensitive electronic equipment. This is achieved by providing a separate grounding path that is isolated from the regular equipment grounding system. Secondly, the isolated ground conductor must be insulated to prevent it from coming into contact with other grounded surfaces. This insulation helps to maintain the isolation of the grounding path and prevent noise from coupling into the circuit. Thirdly, the equipment grounding conductor provides a path for fault current to return to the source in the event of a ground fault. This conductor is typically connected to the equipment enclosure and provides a low impedance path for fault current, which helps to trip the circuit breaker or fuse and to energize the circuit quickly. When selecting the size of the equipment grounding conductor, refer to National Electrical Code Table 250.122. This table provides guidance on the appropriate size of the equipment grounding conductor based on the size of the overcurrent protection device protecting the circuit. It is important to note that the equipment grounding conductor must be sized large enough to safely carry the available fault current without overheating or causing a fire hazard. When considering the use of armored cable as an equipment grounding conductor, it is important to ensure that the armor is properly bonded to the equipment enclosure and to the grounding electrode system. This bonding ensures that the armor provides a continuous and reliable grounding path. However, some tenants may prefer a separate insulated wire for the equipment grounding conductor, as it can be easier to inspect and test. In some cases, specific equipment requirements may dictate the need for a dedicated equipment grounding conductor. For example, medical equipment or laboratory equipment may require a dedicated equipment grounding conductor to ensure proper grounding and prevent interference. When negotiating with the tenant, it may be helpful to explain the benefits of using armored cable as an equipment grounding conductor. Armored cable provides excellent mechanical protection for the conductors and can be a cost-effective grounding solution. However, it is important to be flexible and willing to accommodate the tenant's preferences if possible. If the tenant insists on a separate insulated wire for the equipment grounding conductor, it is important to ensure that the conductor is properly sized and installed in accordance with the National Electrical Code. The conductor should be run in the same raceway as the circuit conductors and should be connected to the equipment enclosure and to the grounding electrode system. When seeking approval from a higher authority, it is important to provide all relevant information about the situation, including the code requirements, the tenant's preferences, and the potential costs and benefits of each option. The building owner or electrical inspector can then make an informed decision based on the specific circumstances. In addition to the technical aspects of isolated ground circuits, it is also important to consider the legal and contractual aspects. The lease agreement or other contract between a landlord and tenant may specify the requirements for electrical installations. It is important to review the contract carefully to ensure that the proposed installation complies with all applicable requirements. If there is any ambiguity or uncertainty, it may be necessary to consult with an attorney. Understanding the different types of grounding systems is also crucial for ensuring electrical safety. There are mainly 3 types of grounding systems, including the grounded system, the ungrounded system, and the impedance grounded system. In a grounded system, one of the current carrying conductors is intentionally grounded. This provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse and to energize the circuit quickly. Grounded systems are commonly used in residential and commercial buildings. In an ungrounded system, none of the current carrying conductors are intentionally grounded. Ungrounded systems are often used in industrial facilities where a high degree of reliability is required. If a ground fault occurs in an ungrounded system, it will not trip the circuit breaker or fuse. This allows the system to continue operating until the fault can be located and repaired. However, it is important to note that an ungrounded system is more susceptible to voltage transients and surges. In an impedance-grounded system, a resistor or reactor is connected between the neutral point of the system and ground. This impedance limits the amount of fault current that can flow in the event of a ground fault. Impedance-grounded systems are often used in industrial facilities where it is desirable to limit the amount of fault current to protect equipment. Proper grounding is essential for electrical safety. It helps to prevent electric shock, fire, and equipment damage. By understanding the different types of grounding systems and the requirements for isolated ground circuits, you can ensure that your electrical installations are safe and compliant with the National Electrical Code. The size of the equipment grounding conductor, or EG, is crucial for safety. National Electrical Code Table 250.122 dictates the minimum size of the EGC based on the overcurrent protective device. For example, a 20 amp circuit requires at least a number 12 American wire gauge copper EGC. A 30 amp circuit necessitates a number 10 American wire gauge copper EGC. Using an undersized EGC can lead to overheating and potentially dangerous situations during a fault. Type of conductor material also plays a role. Copper is the most common and preferred material due to its excellent conductivity and resistance to corrosion. Aluminum conductors are permitted but require a larger size to achieve equivalent ampacity. When working with metal raceways like conduit, the raceway itself can serve as the EGC if properly installed with listed fittings. However, using a separate insulated EGC within the raceway provides an extra layer of safety and redundancy. This is especially important in critical applications like hospitals or data centers. Isolated ground receptacles are designed to minimize electrical noise. These receptacles have a separate grounding path that is isolated from the normal building ground. This isolation prevents noise from other equipment from interfering with sensitive electronics connected to the isolated ground receptacle. The National Electrical Code requires specific markings for isolated ground receptacles. They must be identified by an orange triangle on the face of the receptacle. This marking helps to ensure that only appropriate equipment is connected to the isolated ground receptacle. Regular inspections and testing are essential for maintaining a safe electrical system. Grounding and impedance testing verifies the effectiveness of the grounding system. Continuity testing ensures that all grounding connections are intact. Insulation resistance testing checks for any insulation breakdown that could lead to a ground fault. Addressing tenant concerns is a crucial part of any electrical project. Open communication and a willingness to explain the rationale behind design choices can often resolve disagreements. Providing documentation such as code compliance reports can help to build trust and demonstrate the safety and reliability of the electrical system. In situations where disagreements persist, seeking the opinion of a qualified third party, such as an electrical engineer or inspector, can provide an objective assessment and help to find a mutually acceptable solution. Remember that electrical safety is paramount. Always follow the National Electrical Code and best practices to ensure the safety of people and property.